Hello dear learners. In our this video we are going to start with our topic probability. In the last video we covered with the topic of linkage and the associated numericals. In this video we will try to discuss the topic of probability in genetics. Now what is the probability? What is its literal meaning? It means the possibilities of occurrence of a particular event. So we say that probability is n upon t, that is number of a particular event upon the total number of events. But this is very general definition of probability. For example, if I say that there is a die and it is thrown once, we have to find out the probability of getting 1 on the dice. We know that a dice contains 6 numbers, so 6 will be in the denominator, that is total number of events, and our desired event is 1 here. So the probability comes out to be 1 by 6. But what if we complicate it a bit further? Let's say if I consider the same dice, but now I am saying that in the dice, what is the probability of getting 2 and 3 once, and then in the later time I get 3. Now how to calculate this? So for this, what do we need to do? And then there is another condition also. Suppose a die is thrown and what is the probability that either 2 or either 3 comes? Then how can we calculate this? Okay, there is little bit of changes. Let us consider that this is one dice and this is another dice, and these two die are thrown simultaneously. Now if they ask that what is the probability that we are getting on one dice 2 and though on the other dice we are getting 3, and here there is only a single dice, but now we are asking that what is the probability of getting either 2 or either 3. So see, there are two different conditions here. Now if you try to consider the second case first, so here we are having either 2 or either 3. So probability of getting number 2 is 1 by 6. Similarly, the probability of getting 3 is also 1 by 6. But we know that the dice will be thrown only once. That means either 2 can appear or either 3 can appear. Means the two of them are not depending upon each other. In that condition, we can say that the two events are mutually exclusive because they do not involve each other. Either the 2 can come or the 3 can come. So here we say that if the two events are mutually exclusive, that time the probability can be 1 by 6 plus 1 by 6. That is, we can get 2 by 6, or we can say 1 by 3. Let's take this example from our biology also. Suppose a baby is to be born. Now what is the probability that it can be a male or it can be a female? We know that male probability is half and the female probability is also half. And because the two events are mutually exclusive, we will add them. So it comes out to be 1. So always remember that whenever the two events come out to be mutually exclusive, that means either one can happen or the another can happen. In that condition, we use the addition rule. This is the first important thing. So addition rule is used for mutually exclusive events. Now let's consider another important example. Suppose we have two parents. The blood group of one parent is Ia small I and the blood group of another parent is Ib small I. Means here we have the parent with A blood group and here we have the parent with B blood group. Now they are asking that what is the probability of a sibling with the either A blood group or B blood group. So we know that if we conduct the cross of the above these ones, so what can we get here? So if we are considering these two cases here, we can get either IAIB. Wait, we can either get IAIB or we can get IA small I, or we can get IB small I, or we can get II. So in this condition, either A or either B. See, for A it can be out of 4 events, so it is 1 by 4. For B also it should be 1 by 4. And if we are telling that either this or either that, always remember that whenever I am using this term either, that is always the exclusion. So these are the exclusive events. So here 1 by 4 and 1 by 4 will be added. So here we can get, sorry, 2 by 4, that is 1 by 2. So this is one of the most important fundamental concepts related to the addition rule. Now if I talk about the multiplication rule, what is the meaning of multiplication rule or the product rule? So here it is. Product rule is used when the occurrence of one event is not dependent on the occurrence of another event. In other words, we are dealing with the independent events. For instance, when two dice are thrown simultaneously, the probability of getting a 2 and 3 in that order are. Now see, if I am talking about here, as I was already talking with this example, let's take one dice and let's take another dice. Here if we are getting 2 and here if we are getting 3, so we know that the probability here of getting the 2 should be 1 by 6 and here it should be 1 by 6. But the two are not mutually exclusive because they are not even mutual. They do not depend on each other. That time we say that the overall probability should be multiplied. That is the product rule. So it is 36 and 1. So it should be around 0.028. So this rule is called as the product rule. So whenever the two events are not dependent on each other, means they are not mutual, that time it is the product rule. And whenever they are mutual but mutual they are exclusive, means either this or either that, we have the addition rule or the sum rule. Now let's solve some problem. Take this example here. The example says that a woman, it is actually woman not a man, so it is she is a female. So a woman basically with the hemophilia marries a man and who is normal for the trait. Now woman is hemophilic, so we can say that, and because we know that hemophilia is X-linked recessive disease, and because here woman is affected, that means that both of the X should have that disease. She is marrying a man who has the normal phenotype. Now what happens is they have a daughter of again a normal phenotype. So now they are having a daughter. We know that one X chromosome comes from here and one X chromosome comes from here, so it would be like this way, right? So in this condition the daughter is obviously a carrier. So what is the probability of that daughter of this meeting will be hemophilic? So now you see yourself, you just imagine this condition that we can have the daughters where one X chromosome will be from father and one X chromosome would be from mother. Now always in the case of mother the X chromosome will be affected, but in the case of father the X chromosome would not be affected. So in that condition the female can be a carrier but it will never be infected. So here the probability turns out to be 0%. If the couple has 4 sons, what is the probability that all 4 of them will born will be hemophilic? So now you see, if the son is born, we know that son contains X and Y chromosome. This X he borrows from his mother and this Y he borrows from his father. Now father is completely normal but mother is infected. So every time X chromosome comes will be infected one. So here we can say that 100% chances are there that whoever son will be born will always be affected. But the daughters would never be affected. That is a 0% chance. So it is a very simple case and a question of probability. Let's move into detailed ones now. Before moving into detailed questions, let me make out one more example in front of you so that the questions become easy to solve. See, there is a theorem which we call as binomial theorem. Now, according to this binomial theorem, it is very same. The main function of this is to calculate the probability only. The probability from the binomial theorem can be calculated when we have the two different events here given and then we are asked accordingly. So the formula is n. N is talking about the total number of events. Okay, so these are not events, these are the two conditions, what we can say. So the factorial of n upon the factorial of s, the factorial of t, then in bracket we have p to the power s and q to the power t. This is what the binomial theorem is. Now binomial theorem is applicable because whenever we are using the product rule, and whenever we are using the sum rule, these are only limited to the conditions where the data given is very less. That time we could have easily applied the product rule and sum rule, but when the data set or the data exceeds then the limit, that time we have to solve it through binomial theorem only. The another important thing that we have to solve probability questions is the Pascal's law or Pascal's theorem, so we should also come on to that later on. Now let's try to solve this question. The question says, assuming a sex ratio of 1:1, what is the probability that a family of 4 children, so there are 4 children, so we can say that n counts to be 4, will consist of 3 daughters and 1 son. So see, here we cannot use directly, the formulas for addition or product rule. We have to simply use here the binomial theorem. It is so because the question solving becomes way too easy. So we know according to binomial theorem it is n factorial upon s factorial p factorial. Here we have s and here q and then we have t. Now n is the total number of events. Here n turns out to be 4. S. Now what is S? S is the frequency of one event. So daughter's event it is 3 and T is the frequency of another event which is 1. Now P is the probability of having a daughter or probability of having that event. So because we know that these are only the two events, so one of them has to happen, so the probability of P is also half and Q is also half. So simply by putting into the formula we can have 4 factorial upon 3 factorial multiply by 1 factorial multiply by half to the power 3 multiply by half to the power 1. So here we can get it as 4 into 3 into 2 into 1. That is the formula. How do we solve factorials? It is 3 into 2 into 1 and this is 1. Here we can get 2 multiply by 2 multiply by 2 and here also multiply by 2. Now this 2 and 2 gets cancelled, 3 and 3 gets cancelled, 4 cancelled by 2, and now we are left with 1 upon 2 multiply by 1 upon 2. So the answer comes out to be 1 by 4. So this is the probability and it's as simple as that. But here, wait, we do have a twist here. The twist is that in the condition, if you do not know how to solve the factorials, then you cannot solve this question. So you have to remember that how do we calculate factorials. So for calculating the factorials, always remember that we have to also include that number, because this is what common mistakes we do while we solve the questions. Suppose for the factorial of 4 we start writing 3 multiplied by 2 multiplied by 1, but no, it is 4 3 2 1. For 3 it is 3 2 1 and for 1 it is 1 itself. That is the main thing you need to know, otherwise the twists would happen surely. The next possible question can be that what is the probability of having the uh, all daughters? That is the B part. That what if we have all the daughters? So now it is very simple question, but still we can apply the formula also. The number of events were 4 because we have 4 children. Now